Hi, this is Jesse Randolph with Global Water Instrumentation. I'd like to thank you all for joining us this morning and taking some time out of your busy work schedules. We're going to go ahead and place a hold just for a few more minutes and allow any latecomers to go ahead and log in. So once we get started, remember to pull up the side thing so I can kind of see, so I know what's coming next.
The side, please.
On the side, I can see all of them. It'll help me out a little bit. I gotta go to the bathroom.
All right, Jesse, could you start, please?
Yes, hello everyone. This is Felipe Zambrano. I'm the product line manager for Global Water. I want to thank you for joining us into this webinar this morning. I have been 20 years here working at OI Corporation. So about 2009, we were acquired by ITT, and then in 2011, ITT was split into 3 different companies, and one of those companies was Xylem, and then Global Water, which was based in California, was moved to the facility in Texas, where I am. And instead of being an independent company, when it was moved to Texas, it became a product line. So the name of our company here in Texas is OI Corporation, and product Global Water is just a product here. And the person who has the most experience about these products is Jesse Randolph, which is here with me, and he's going to start explaining more about our products. I just want to let you know that at the bottom of your screen, probably on the right-hand side corner at the bottom, there is a chat window where you can start writing your questions, but those questions are going to be answered at the end of the presentation. So go ahead.
Hi, this is Jesse. I'd like to kind of pick up where Felipe just left off and welcome you all. We're all glad you had the time this morning to join us here, which we're hoping to be one of many global water presentations to come over this year, next year, and going forward. We're going to try to do one every quarter, starting with water level, moving into samplers, flow, water quality, so on and so on, remote monitoring, and etc. Like Felipe mentioned, I started back in California with Global Water at the Gold River location, moving into my 18th year now, almost 19th year. So when I had the opportunity for the relocation, once Xylem came along, I saw it as a great opportunity to further my education and water career. So I jumped on board and packed up my bags and moved here to Texas. So we just pulled up a second slide here for you, which kind of breaks down a lot of these Xylem analytics companies and where they are located worldwide. You can see there we have OI Analytical circled there with an arrow kind of pointing into Texas. That's where we're located. And from this facility, we focus on one, Global Water. Two, we got the OI Analytical. We do a lot of the VTV product line here that we support in North America. Well, there's Voice Technologies, SI Analytics, and the Ebro product line. We do have some service for Bellingham and Stanley also come through the building here. And like we mentioned, we are an American-based company, so we have a nice little area view of our building here in College Station, Texas there. We're right down the road from the Texas A&M University. And again, we have a little map there, putting a little star on our location. We're located not too far outside Houston, San Antonio, Austin, which is the capital here in Texas. We got a good central location here in Texas. It makes it easy for transportation of goods domestically as well as internationally. We got next coming up a few screenshots of what we've taken of our production, where our qualified technicians go through the manufacturing of all of the level instrumentation here at this particular work center. We do try to be a very lean, organized company as we have to follow ISO procedures. So each one of our techs have a documented procedure they have to follow for each piece of instrumentation that they have to manufacture, ranging as we go through here, the submersible sensor to the non-contact. For all the sensors, there's again detailed procedures for quality checkout as well as for manufacturing. So this is kind of be our table of contents. We're kind of scroll through each one of the products relatively quickly. We're not going to focus on a whole lot of all the technical information. I could go on and on for probably 4 or 5 hours about that. A lot of that information, if you decide you want to look at more closely to some of the products, is going to be available on the Global Water website. We have our brochures, specifications. We're going to try to touch briefly on some of that, as well as just show you some pictures and talk about installation and application. And then, I mean, you can always reach out to us directly later on if you need more information. So as per the table of contents, we're going to start talking briefly here about the Submersible WL400, which is a manufactured pressure sensor from Global Water. It has a submersible pressure transducer, and we'll get into some of the specs here in a minute, going from 3 feet up to 500. But here are a few pictures of the installation. You can kind of see over, if we go left to right, we have kind of an open well where we have the ultrasonic sensor submerged down in some freshly water. We want to kind of keep any kind of contaminants or debris away from the sensor. So we always recommend putting into some type of stealing well, which is basically a secondary pipe system inside of the well, whether it's EMT, PVC, rigid pipe, something that will protect the sensor from any type of damage. Again, whether it's debris or a pump system or something kicking on for overpressuring issues. And we recommend during that installation, you put some kind of preparations on the pipe to allow the fresh water to filter in and keep the debris on the outside so we don't damage our equipment. Here in the center, we have, if any of you have been with us for a while, we have our old salesperson, Renee Cruz. He's out there installing one of our trusted WL16. When we get into open streams, we recommend coming down cross-sectional. So you can see, as well as the center picture, as well as the bottom picture over to the left, as we're going down into a more of a larger channel. We come down into the channel, directly cross-sectional, and as we go out into the stream, we recommend putting a 45-degree angle and kind of positioning a little bit upstream where your preparations are to allow the water to then filter in. So this screenshot here is to kind of get into how the global water pressure sensor functions. What is its purpose? What does it do? Type of slide. So we can kind of see the global water sensor from the bottom corner is a relative pressure sensor. It needs to be vented to the atmosphere. So that's why we have vented cable. The sensor across from it, or the picture across from it, is an absolute pressure sensor, which we will get into later on. We have some non-vented cable sensors, which are more of your absolute pressure. And they require some additional equipment for converting over into actual true water level. But you can see at the top picture there, that's kind of how majority of all our submersible pressure sensors are going to function. So as we come in from the right, you can see the little arrow kind of comes in. So water pressure penetrates through the little channel there of the submersible pressure transmitter. It gets up in the center there where we're going to have on the WL400, the manufactured sensor, it has a silicone diaphragm, which acts as a balloon. So as water pressure comes in, it pushes against the diaphragm, which then travels an electrical signal over through some resistance or resistors, gets to our logic board, and then it's going to produce a 4 to 20 milliamp signal based on the type of diaphragm that we've positioned in there and the type of configuration we put onto our logic boards. Here, getting to the absolute pressure sensor that we just spoke of, we have what's called on the left-hand side, the DCX22. And you can see with the DCX22, we don't have any vented cable. So here you're going to have a cost value possibly in savings, because when you go to submerge the DCX22, you're not having to pay the $3 per foot of the cable, which is a high quality cable that Global Water uses, which is ventilation. You can put anything from just a chain to some string, to a rope, to whatever kind of material you can get your hands on for installation. Across from that, we have the relative pressure sensor, again, which is a manufactured global water sensor. We have some information there you can read over, but the main thing I want you to focus on is the type of cable. So you can see it is a vented cable. So we have our vent tube traveling through the inside, which is crucial for insulation. You don't get any kinks or bends, because if we don't get a good vent to the atmosphere, your data is going to come out all jumbled. You're going to be, hey, what's going on? I don't understand. Why is my data all over the place from 3 feet to 20 feet to 9 feet? It's just going to be all over the place. So it's crucial to keep that vent tube clear. Around the vent tube, we have the 22 gauge wire, basically 4 gauge. We have red, white, black, and green. The red and the black is going to be the loop 4 to 20 output. You have your power and you have your signal return on the ground. There is a white wire. If you require temperature, we can activate the temperature for you, and the sensor can also output temperature. That was the WL400, and we're going to move on now and get into a little more information on the 400. So we also have here some more digital pictures for you to enjoy. And we have some applications here. We have water level, water depth, groundwater, surface water, pipe flow, water pressure, agriculture, wastewater, surface water, ocean, coastal water, et cetera, et cetera. We have plenty of applications the 400 is suited for. But you can see here, we have the picture from before. We have a nice weatherproof enclosure off to the side of the left. And then as we go over to the right, we have the sensor coming in with some other equipment that is non-global water. But you can see we have for global water a gray Pelican enclosure with a GL500U 2-1 4 to 20 milliamp data recorder. And another thing I just really quickly is the nice thing about the analog sensor, whether it's analog or 0 to 5 volts, it can be integrated into a large number of instrumentation that is non-global water related. So here are some of the specifications for the global water WL400. Again, it is an analog output sensor. We list it as 4 to 20, but if you put a multimeter on there, you're going to get closer to 4 to 19 milliamps. The accuracy is 0.1% at a constant temperature, which we calibrate here in-house through ice bath. And then we have our pressure ranges here. We go from 3 feet at the 0.91 meters all the way up to having a 500-foot submersible transmitter available. And then we have the cable lengths where we have here maximum 305. We can get up, I think, close to 2,000 feet. We just need to know in advance so we can special order any type of cable for you. CE certified, and again, we have a temperature output option if that's something you require with your application. Moving back over, we have another shot here of your cable. You can see here the type of material the cable is manufactured of. Again, we have the vent tube, which is crucial to have it vented to the atmosphere. Once you get it vented to the atmosphere, you're welcome to go ahead and splice on any cable you can get your hands on to run the signal farther away. If you're coming out of a stream or you're on an industrial plant, you have your pump house over here, and then you want to run another 100, 200, 500 feet away. As long as you get some 22 gauge cable, you can then splice it on as long as you vent it to the atmosphere, run it farther away. We also have here in the center something we like to offer, which is our Desiccant pack. So getting into humidity or moisture buildup in the vent tube is almost like having a kink in your installation. So any moisture buildup as we are being vented out to the atmosphere is going to cause spikes in your data. So it's crucial to get some kind of venting system. We have here a Desiccant option, which connects to a tube either directly into the end of the 400, or in our screenshot here, we have our WL16 USB, which that way can suck out any moisture if we're maybe underground or in a high humidity area. We have here some WR400 options. We have two of our more popular ones here, which is the WLSWO sewer flow option. You can see it's a stainless steel sheet with kind of a plastic mouse looking little thing to drill it into it. The WL400 kind of slides in there. It's meant for sewer application, or if you're getting into a vault down in a manhole and you have a sewer pipe and you want it to be held in place, this can actually be mounted into the pipe or an open channel flume or weir of some kind and hold the sensor in place so it doesn't get lifted up in a high velocity event. We have the Easy 100 display here, which is available battery or AC powered, and basically displays your water level readings. Some other options before we go forward on the WL400 I wanted to point out is it is available with stainless steel. It also is available with a PVC threaded option, which is good for ocean and coastal because stainless steel can be corroded. We also have a titanium housing available with no threads. And with the 400, we also manufacture a vacuum type sensor. And with the accessories, we have all our data recorders, telemetry systems, radios, transmitters, which we'll get into later on. So we're going to move away from the WL400 and we're going to jump into the WL16. And we're going to integrate a little bit here with one of our flow loggers, the FL16, because the WL16 and the FL16 are almost identical, aside for some software, a few different modifications to the sensor. So we have some more application notes here for you guys. We have groundwater monitoring. Again, we get into streams and rivers, lakes and ponds, flood events, governmental applications, anything with your local and state organizations that may need help monitoring water for reporting purposes, emergency broadcasting, news reports, whatever it may be that you have an opportunity to get out there and try to solve some water. So real on the pictures here. So we have one over here, kind of shows, again, a picture going, kind of mounted up on some post or tree, and then where we kind of have an insulation going down to put the sensor into the stream, but we want to keep the data logger portion of the WL16, which is connected to the 400, up high, because during a flood event, only the 400 is going to be rated for submersion. The actual WL16, which is going to house the USB logger interface, needs to be up out of the reach of any kind of flood event, water or moisture. So that's why we have, again, the Desiccant option, as well as the internal Desiccants. So you can see that we have in the center there, we have a V-notch weir, where we have just a large post with some PVC housing. And you can see this gentleman here, he has a WL16 with his laptop. He's downloading some data with his USB interface. And then farther over here, we have a gentleman who has, which I believe is a 4-inch PVC pipe fixated onto a side of a bridge. which is then going down, and he's dropped that down X amount of feet to monitor the water level as it travels beneath this overpass of a bridge. Here are the specifications for the WO16. You can see the key specifications are, it does have 2 internal batteries. We ship everything with alkaline batteries. You have your memory here, up to 81,000 readings. You have your software, which is USB interface. And we have a note here that all Global Water software is compatible all the way up to Windows 10, USB drivers as well as the software. And we have a quick note here of the different sampling modes. So if you do make a purchase or you do have one, you probably notice or you'll see, we have a fast sampling mode where you can take a reading 10 times per second, a logarithmic mode, and some exception mode. Some of these are crucial if you're doing in a well sludge test. And just real quickly, a sludge test is if you have this WO16 down at the bottom of the well, you may turn on your logarithmic or your 10 times per second mode and you drop a weight down the well. And as weight travels through the different sludge and material, we see the change in the level, which is then recorded 10 times, or if logarithmic, you're getting multiple readings per millisecond. So you can capture that data to see how long it will take, say, for 100 feet for this weighted weight to travel down through the sludge and get down to the bottom where the level sensor is located. And then we have some of our Desiccant pictures here. And we made a note here about stop alarms and some field setup notes at the bottom there. This is a quick picture of the flow monitor software, which is very close to the WO16 software. With the WO16, you're just going to have access to water level, which going from left to right, you can see here we have channel 1. At the top here, we have 3 for 3 feet. So this particular transmitter is going to read 0 to 3 feet, and we're displaying here 1.145 feet of water level. Next to that, we have the temperature option turned on, so we're reading 61.4 degrees temperature. Every one of our softwares now, they actually record the battery voltage, give you a little reminder when you got to swap out some batteries. And then we move over to where with the FL16 and or even the WO16, if you run the flow monitor software, you have access to get into flow and velocity readings based on configurations. So this particular shot shows you the Manning's equations and configuration notes, which we can get into later. The last picture over gets into the setup menu of the software, over into the analog channel, which is actually where all the calibration value is met. So you can see here again, the high engineering unit is 3, which matches our screenshot for your level. Then we have the high and the low raw values, which your high raw value is basically bytes or resolution value to be equal to your 420 milliamp output. Very user-friendly software. It's very easy to navigate through. Here's a screenshot of the software once you get into the flow monitor setup where you get into your flow calculation. So you can see you have no flow calculation, Manning's, Flumeware, or your table file. We have a lot of pre-programmed files for you to choose from. But if we do get into an application where you have an open channel, you don't have it, we don't have it as a lookup table. You can create your own lookup table here. Once you've created your own lookup table, you can then go ahead and download it through the table file and upload an application file for anything from a hydrological dam or to an open channel, which is not predefined in one of our lookup tables. And we have a few examples of some of our lookup tables there far over to the right, from Palmer Bolus to some V-notches that we've pre-programmed. So we're going to move away from some of the WO16, the WO400, and the flow logger, and we're going to jump over to the WO430. So the WO430 is a very large, robust, heavy-duty sensor for when you get into some real nasty, sludgy, dirty water, which maybe the WO400 with the stainless steel sensor is just not going to hold up real well. The thing with the 400 is also the diaphragm. It has a silicone diaphragm, which can be corrosive to different materials, can destroy the diaphragm. So with the 430, we have a very much larger, robust piece of equipment here. You can see the different certifications available there for it listed. Also with this sensor, the diaphragm is no longer silicone. We have a stainless steel diaphragm with some mineral oil kind of trapped there at the end. It also outputs a 4 to 20 sensor, so as pressure is applied to it, it will output the 4 to 20, very similar to the W400, except the application is going to change, where we're getting into a very thick mud, or you're going into a treatment plant to some influent or some real thick waste where you just want something a little bit more heavy duty. As far as the 430, your typical installations, here's a little diagram we set up. We kind of show here, or we have our sewer inflow kind of coming into some underground tank or vault. We then show the steel cage sensor there with our arrow kind of pointing up so you can see where it's at. Kind of submerged there in the sewage, human feces, whatever it may be, traveling up to our control panel. And then we have some lift pumps that are then pumping that sewage and waste out, whether it's going to go then be treated, or once it's treated, it's going to be then discharged back into the environment. Another one of the level transmitters we have to offer is our popular WO450, which is very, very going to be similar to the WO400 in a lot of ways. A lot of the applications are going to be very similar. We get into more environmental monitoring, wells, surface water, groundwater, hydro, again, ocean, local government, industrial, commercial, for all the sensors. So here's a picture of what we have for the WO450. Now the WO450 is also going to be manufactured of stainless steel, like the WO400. The difference between the two is the WO450 also is going to have a stainless steel diaphragm, where the WO400 has a silicone diaphragm. So if we get into any contaminants in the water, such as high levels of chlorine, magnesium, depends on what the application is calling for. If we know of a known chemical, we can look this up off of a website and do chemical compatibility. The other nice thing that's not on the slide here about the 450, we also have a titanium version available for the 450. So if we get into coastal monitoring or high levels of chlorine, stainless steel, it does not work well with high levels of chlorine, so we can then chop you over to the titanium, which is going to be much more durable material. It also has analog output, 4 to 20 milliamps. The nice thing we have now available with the WO450 is it has now SDI 12 option. Well, it'll be two different models. You can purchase it with the 4 to 20 milliamp, also as RS485, and or now it's going to have SDI 12 option. The accuracy here is plus or minus 1%. The ranges here go from 3 feet. We have listed 500, but that's incorrect. It goes from 3 feet to 900 feet. So we can get a larger range on the WO450 than we can with the WO400. Cable length about the same, 2,000 or 3,000. With a lot of the sensors with the 450, if we start to exceed a certain amount of cable, here we have 500 feet. That's again, not necessarily true, but if we were to start exceed maybe 500 feet, then a lot of times we're going to recommend a power booster where you're going to get a supply voltage above 12 volts. And I say 12 volts is our equipment outputs 12 volts. But if you have something that can output a direct 24 volts, you're fine. We recommend a booster if it's something we're integrating for you. So now we're going to jump over to the self-contained data recorder, which is the DCX22. And we have some application notes for you here. Like I mentioned before, the DCX22 is more efficient when you get into cost if you don't have to run a lot of cable. Because the high quality cable that Global Water uses, once you start exceeding 25, 50, 100 feet, you're going to start to accumulate cost, which would exceed the value possibly that you're wanting to spend. So you can go here to the the DCX22, which doesn't have any cable. So you can meet a lot more applications here. And we have the specifications here on the DCX22. It has an internal battery, which has a battery life of about 10 years. So you don't really have to necessarily worry about always changing out your battery. Even with the WO16, with your internal 9-volt batteries, you're losing about 8 months. You can see we have an extended life here on the DCX22. The range is available on the DCX22. We have two models. One goes at 32.8, the other one jumps up to 65.8. Those are the ranges of pressure and feet. And you can see here the crucial thing is the barrel logger. It says barrel accuracy is 1 millibar. Because we don't have the vented option on here with the cable, we got to know what the barometric pressure is at the same sea level elevation. So what we do is this records level. We record the barometric pressure. We download them through software or through Excel. You take the water level, you take your barometric pressure reading, you subtract it, then you're going to get the true actual water level reading. We do have the cost between the DCX and the barrel are relatively the same. But again, the cost value is you don't have to spend the money on the cable, and it does have a built-in data recorder, so it can record. You can see the memory here is 16,000 up toward maybe 28,000 data points. Finally, we're going to jump over away from our submersible types, which meet a lot of your application needs. But in case we get into a rough environment, depending on what it may be, we just don't have the ability to put down a submersible sensor. We're going to want to go into maybe a non-contact sensor. So here we have the first slide over toward the left. We've kind of circled it there so you can identify it. That is going to be the global water radar sensor, which is available with two models. We have aluminum as well as stainless steel. And the radar sensor has its own applications where it's recommended versus if you jump over to the other side here in the picture, we have the WO705. Where the WO705 is more cost effective and it meets its own application, which are maybe going to be a little bit more environmental for you. And then in the center here, we kind of give a breakdown of how the actual non-contact sensor works. I mean, you have a beam angle that you need to take into effect, which is about a 12-degree beam angle to make sure we get an accurate bounce back without any interference. So here we have another shot of the ultrasonic WO705 global water sensor, which is all threaded. It's a nice stainless steel sensor, so it can be threaded into mounting hardware, which allows for easy installation. Here we have the 3-foot version. So basically 3 feet away from the water surface with the 12-degree beam angle, it'll bounce off the water surface, send a signal back up, and the signal gets captured and relayed over. In this case, we have a telemetry system there with a solar panel. So the data is captured and then transmitted back out to you. And if we get into the telemetry systems, there's also systems we have that will take that level reading as well as the software, and we can calculate that into a volume and velocity if we have the right information from you guys. Here are a few pictures of the WO705. So the larger one there is the larger measuring range. So it can measure all the way up to 48 feet. The one next to it, which is the stainless steel version, it has a 3-foot as well as 12-foot available models. And you can see here we have the cable length where if we start getting over 500 feet, we're going to need to put in a booster. So we want to boost up the signal to make sure we have power to ensure the accuracy coming from the ultrasonic sensor. The outputs here are 4 to 20 milliamps, as well as you have RS-485 output. And if you use RS-485, you can go up to 4,000 feet. Because the RS-485 signal can travel for a huge distance without any electrical breakdown. The crucial thing is with the cable length again. That's if you're having to bring in a supply voltage. But it has its CE certification and its dimensions are there, and it meets a lot of key applications where you just don't want to put a sensor down into the water. You need something non-contact. We're going to jump away from that one, and now we're going to try to touch real quickly here on the 900, which is, you can see the picture here, which is a radar sensor. The primary function of the radar sensor, in my opinion, is not necessarily always going to be the environmental function. This is where we're going to get into more of a fracturing industrial application where you're going to be in some kind of processing tank. One that comes to mind that I've worked on just recently was with a concrete manufacturer. So they're mixing up concrete. Yes, we're not dealing with water anymore, but the nice thing about any of the non-contact sensor, it's just bouncing off the surface of any material. So we can put this into a tank that's manufacturing concrete, for example, on an industrial plant, and your trucks are driving underneath this and it's dumping in the concrete, and they can use this to monitor. So when the concrete level gets down, they stop the flow of the trucks driving through there. They know, oh, we got an alarm, we're running out of material here. Kick it on, they refill it back up, they grind up all the rocks. And with the radar sensor, you can penetrate down through a lot of debris and foam and just little particles floating around in the air. The ultrasonic can penetrate that, where the WO705, the non-radar version, will have interference. And here's a nice screenshot of the radar sensor with its specifications. And you can see, like most all global water equipment, it's a 4 to 20 output. It has one standard range, which is 10 to 50 feet. The standard upper portion of the radar sensor, again, is aluminum or stainless steel. And it has recently been redesigned. So if you're looking at the picture there and you see the large funnel, right above that funnel material, we did encounter some possible, again, because we get into where there's debris and particles in the air that were causing slight corrosion. So the bottom portion now has been redesigned, is now a Teflon. So you have the Teflon coming up there at the bottom, but the upper portion that is housing electronics is still stainless steel and aluminum, and then the bottom is now manufactured with Teflon. You can see here you got push button calibration, you have your cable lengths, you have options for AC or DC power, depending on the application. And there's a little button when you open up the top to do your field calibration if you need to. Now we're going to navigate over to the reel option, which is the WL500, which is an oldie but goodie for installations. Multiple sizes of tapes available, measuring units going from meters to feet. Here we have it listed available up to 150 meters. We do now have larger ranges available. I checked, we have a new manufacturer where we're now going up toward, we can get to 925 meters. So we can get much deeper than what we have listed here. Again, we can go 925, but basically it's the same. We have a few different types of reels available depending on the length. Polypropylene is the standard reel. If you're monitoring under 100 meters of tape, you're going to get that type of reel. If you go up above 100 and you jump to say 150, or you're going up to 300 meters or 900 something, the material is going to change to a steel or aluminum type reel, because you obviously need to support the weight of the tape. They're nice and simple, where you don't need to have something permanently installed to capture the water. You go out to your well, you drop the tape down there, at the contact with the water surface, it makes a large beeping sound for you and has a red flashing light. You can see over here to the side, we have an installation, excuse me, where we have two WL16 permanently installed that are recording the actual water depth. And then the customer has their tape reel. They just want to verify what the distance is going to be to the water surface. Now note, just real quickly for applications, on the WL16, you do have your engineering units. So as well as just reading water level, we can adjust your engineering unit so you're getting elevation as well as depth of water. So necessarily, sometimes you may not need the tape, but the tape is always something that we like to have as an oldie, we call oldie but goodie, because you can always use it in a lot of applications. We don't need a WL16. So we have some more information here on the WL500 as well as the WL550. And the 550 is going to be your oil water interface analyzer, which is identical, besides some of the material and the material in which the tape is manufactured for durability and chemical resistance. They both now, with some of the newer model that we have here in the picture, it does show the sounder physically attached to the cable. So it is available with both. We can have it permanently attached, or there are fittings now on the end of the transmitter, makes it easy to detach. You can take it on and off, and that's good in case you get something hung up or it possibly gets damaged. Easy to replace with your field replaceable transmitter there in the end. One of the other non-contact sensors we have available for well monitoring is the WL650. This is where we get in, where we have the WL500 with your large tape. You got to carry that heavy piece of material out there where you may have 900 feet or 300 meters of cable on here, and you don't want to necessarily wheel that thing out there and drop it down the well. So with the WL650 sonic water level meter, with its technology, we have a built-in microphone, which is almost, to compare it, we can get into like ultrasonic, but it's slightly different. But basically, we go up, we can put it into a well. We have some few settings. We want to adjust some temperature for the speed at which the signal is traveling down the well and the bounce back. But basically, we push the button when we get it in there. It's going to travel. It's going to ricochet off the side of your wells. It's going to hit the water surface. It's going to bounce back and give you a little digital readout of what the actual distance is from the top of your well casing down to the water surface. And don't worry if you're getting into an application where your well is old and it's cracking, you got roots busting through the side. You think, oh, my signal is going to hit a root and I'm not going to get any readback. We do have sensitivity adjustments on this WL650, so we can adjust some of the sensitivity. So we tell the instrument, hey, we're going to have some cracking, and we may have some roots or something that have penetrated through this well, and we should be able to possibly work around it. But the nice thing is if it's completely destroyed and we have no option, we can always default back to the WL500 tape. As we get near the end here and we start getting ready to wrap things up on one of our last few slides, we're going to talk about the WA600, one of our alarm sensors. Excuse me. So the WA600 it basically has contacts on the inside of this. If you're looking at the picture here, over toward the right, we have a nice PVC enclosure with, in the center there is a sounder, and then we have mounting clips, and then we have a little red flashing light at the top of the unit. And with this particular sensor, it has the input of a switch closer. So we have a few example of switch closure sensors that Global Water offers. We have a WA600 all the way over toward the left, which is a threaded option of a contact sensor, which is going to alarm on contact with air if you get the W version, or excuse me, the A version, or it's going to go on alarm with the W version, which is water. And then it'll kick on the sounder. Then next to it, we have a float switch and a chemical resistant bag. And then next to that, we have a secondary float switch with a slosh shield to protect the internal ball valve. And basically water level rises and closes the ball valves, get pushed up and down to trigger on the sounder. The sounder also has a 12 volt and a control switch output, which we find a lot of people use in dam applications. Even people here in North America, they put these in the basement of their houses by their water heaters. So if your water heater bursts and you start flooding water in your basement, you put your sounder there, it's going to start going off, and you put a switch, cut off the solenoid, turn the water off so you're not flooding your basement, and it makes enough noise to wake you up while you're sleeping. Or we put them on side of dams or in industries where you need a visual effect. You can see the light flashing. You got your people, hey, I got to run over here. As well as with the output, you can run the contact switch closer output to a secondary device like an auto dialer, so you get a phone call to someone. We have our Storm 3. It's going to send out some SNS signals for you, so you're also getting the output version to another contact device, as well as you're getting on-site sound with the visual effects there. So this kind of just to wrap everything up. And again, I'd like to thank all of you for showing up. And I think I exceeded my allowed 20 minutes, but like I said, I can always talk for much longer than that on water level. It's one of my passions. So we went through water level, we did some flow. We also have available samplers. We have water quality, we have weather, and we're going to try to do one of these webinars once every quarter, and we'll try to make them better with some visual effects, maybe some videos as we get more familiar with the whole process. So as we go to the next slide, we're going to get into any questions that you may have emailed in. We'll try to answer as many as we possibly can right here, right now. If we're unable to, they will be sent over to me and Felipe as well as Justin personally, and we'll address them at a later date. Or in the future, if you have any questions, you can email any three of us at any time. So we'll go ahead and open it up for some question and answer at this time.
Okay, thanks Felipe and Jesse. That was good, and everyone else that's taken the time to attend the webinar, it's appreciated. Before we go into, there's a few questions that came in, but before we do that, I just want to remind everyone that there'll be a follow-up email next week, and in that email we'll have the recording of the webinar, a link to this PowerPoint, as well as the full list of questions and answers. So there was a question here, Jesse and Felipe. It's quite a good one. My understanding was that vented cables greater than around 50 meters made the data look quite noisy. So this product, I think it was the WL400, can have a vented cable up to 300 meters and still have good data. Question mark. Can you elaborate a bit more on that?
So yes, I mean, the cable can go up to the 300 meters, up to 2,000 feet. If we start to see interference, there's something else interfering with the data output. And that's depending on the model. We want to look at the voltage that we're supplying to the transmitter to make sure we got a good supply voltage. That's number one we want to check. We want to check for moisture or any kind of bends in the venting cable to make sure we don't have any blockage for the pressure to then be vented out to the atmosphere. And then the final thing is we want to look at is where are we installed? Are we in some kind of plant we're going to have any kind of electrical or magnetic interference on the cable? With our standard cable, that is normally not the case. But we have encountered very slightly, maybe 5% of the, maybe 3% of the time where there is some type of interference. So to take note, if we went back to one of the slides, we can take the shield around the actual cable that Global Water manufactures, and that can be tied into a ground, or we can even sometimes in cases we've tied that into an earth ground, which in case there is some kind of interference, we can block it out. But typically, again, it falls into a supply voltage issue and checking to make sure we have proper venting as well as some kind of desiccant option to absorb any kind of moisture.
Okay, thanks, Jesse. Maybe we can elaborate with the response with some data showing that over 300 meters, we're not seeing that noise.
Send over that email with the application notes. We'll look at it maybe tomorrow and we'll get out some more information to them.
Okay, great. Look, I think we've taken up enough time for these sessions. We want to try and keep them to 30 minutes. So thanks again to everyone for attending, and we'll get that follow-up email out to you guys next week. And is there any last words, Felipe or Jesse, you want to leave us on?
No, I mean, like we mentioned before, we appreciate all you guys for taking the time this morning. We know everyone's very busy. We hope you all are healthy. We know we got some things going on here worldwide with the corona, so we hope everyone stays healthy. We're putting our prayers out to all of you and your families. And again, any questions you may have regarding, if it's not just water level, but any one of our equipment, please feel free to email us, any one of us directly.
Justin, did you get more questions? No, Justin.
Are there any more emails that need to come over that we can address tomorrow?
Yeah, I think that's it for now, Felipe and Jesse.
Okay.
If any more come in, we'll be sure to forward those on to you and include those into next week's email.
Okay.
All right, thank you.
Thank you very much, everybody. Take care.
Yes, this is too good. I cannot do what he does.
Thank you. Goodbye.
Bye.
All right.